All right, I'm going to move on from wiring diagrams now, okay? What I've given you, and I always tell you what I give you, is just your foundation to work off, okay? You need to get practice, you need to understand what those symbols mean. Some workshop manuals have different symbols than other workshop manuals. I actually find the VAG, that's the Volkswagen Association Group, that's your VWs, your Skodas, your Audis and so on, right? That group of cars, their factory workshop manual to me is quite confusing. They are almost on their own with some of their symbols and how they lay out their workshop manuals. But you know, if you're doing those sort of cars all the time, you get used to their way of doing it, okay? A lot of the aftermarket VAG manuals will be more basic to what we're used to. Most manufacturers are fairly basic in their manual layouts of wiring diagrams, but practice, learn what those symbols mean. Most of them, even though some manufacturers use different symbols for what one other manufacturer would use, you still get used to it, you understand, and some of them are easier to understand than others, but just practice, okay? So, I'm going to start talking about switches again, okay? Most modern cars, we have a computer with a switch. Let's assume that we've got an electric motor like this here, right? At this moment, all the current that we use to run that motor goes through this switch here, okay? So there's a fair bit of current going through. See how thick the wires are to carry that current, okay? So we need to have thick wires, we need heavy current going through that circuit because all that switch is taking a lot of load to run that motor, okay? But modern cars, they don't necessarily do it that way. Most modern cars will use very low current through their switches, okay? This has a very heavy current, this has very heavy current. This has very light current, very, very low current. To tell the computer that has a transistor switch in it, or to run this relay, to take the heavy current to that motor. So all the heavy current that is going through that relay. What's a relay?
Switch.
A relay is a switch. I have a relay, okay, there's a relay of all these wires, but really I'm only, if I look at the switch here, I have one switch here, a push button switch that only needs very thin wire, very low current. But once that relay is activated, as long as there's a power and a ground and it's activated, then I need very thick wire to take the load, okay? So that's why we have relays. Okay? Plus the fact we limit our voltage drop because the longer the wire, what happens? The higher the resistance, the greater the voltage drop. The shorter the wire, obviously less voltage drop, less resistance, all right? So you'll see most computers will control something like a relay. So that most of the current is going to be through that relay in a shorter cable, okay? But very little load on the switch. Some switches use micro switches that just have very little power at all, or very little current, I should say, at all. All right, let's move on. Because we're looking at switches and computers, I want to think anything going into a computer is what we call an input into the computer. Every switch that goes and tells the computer something. For example, I might just use an oil pressure switch, okay, it's a simple idea. An oil pressure switch, when it turns on, or actually it probably opens circuits, right? It probably opens. It will tell the computer, okay, at a very low amp, I've opened up, and now the computer will turn the oil light off, okay? But it's called an input. And we can have, the switch can be a closed switch, or it can be an open switch. And when it closes, okay, it's going to, it could either ground the computer. It could ground the computer, or it could open circuit the computer. It could be either. Doesn't matter. Okay. So we could have power going into the computer. We could have the computer power going out of the computer where we ground on the switch. So we can have a combination of different things. In this case, we've got power coming out of the computer, and when the switch is closed, it's grounded. When the switch is open, it's open circuit. Because we have a resistance built into the computer, see that resistance in there? We have a resistance in that computer. Like I said, every circuit has to have a resistor, okay? It has to have resistance. That's the load. The load is the resistance, okay? We can have a resistor. See that? That's a resistor. Okay? I can comfortably run power on this side, and I can comfortably ground that, and I won't short out the battery because I've got a resistor. I have a load. But it doesn't do anything, okay? All it does is give me a voltage drop and a resistance in the circuit. Okay, so we think about this computer. It's got this resistor in it, okay? So I can now put, and it's also got, not all necessarily has a 5 volt drop down resistor to bring it down to 5 volts. Not every circuit has 5 volts, it could be 12 volts. But in this case, it's got a 5 volt regulator to drop down the voltage to 5 volts. And it will go through that resistance, it will go through to that switch and ground, okay? All right? So, if I was to put a voltmeter on that circuit now while it's been ground, what voltage will I see there?
5 volt.
Sorry?
5 volt.
When it's grounded? It's on the ground.
12 volt.
How much?
12.
Oh, how about we find out? How about we find out? Because
0.
who said 0?
Abhishek Ram.
How about we find out? Because better to be sure than sorry. I need a volunteer, please. Brian, come on.
Number 1 channel.
I need another volunteer. Isaac, come up. Okay. Brian set this to AC. Okay, he was he's made a mistake, so he knows now. See that? That's an AC line for you. You've got to go with DC.
Bulb check करें बढ़िया Bobby.
So this is part of our training, guys, that we learn to use our equipment. Okay, this is good for you. Okay, because okay, right answer. Okay, so when we have our equipment, we need to practice. We need to practice. We need to practice, so we know how to use our equipment properly. Okay, we need to know our settings. So up and down waveform. Or picture on our symbol for voltage means AC. A line with under that with dotted lines means DC. Okay. As a trainer, I should be checking my students. What's Brian done wrong now?
Let me see. Can't see.
Wrong hole.
Wrong hole, bro.
He missed the whole line.
Isaac, call number.
It's got a V for voltage. It goes on V. Okay. So I think I'll be doing some cutting out of this video and fixing it up later. All right.
YouTube पे थोड़ी like नहीं मिली. Wrong hole.
Okay, class. Listen. Right. How do we verify our equipment? We need to find a good ground. We need to find a good power. What's it rating?
5 volts.
Show everyone. Show everyone.
12.96. Yeah.
12 volts.
All right. Leave that one there, Brian. Hold that one there. Now I'm going to do this again. Okay, I've got an open circuit. What am I reading now?
0.
Show everyone.
Zero.
Show everyone.
12.96 again.
Open circuit. All right, now I'm going to close the circuit.
0 volts.
What am I reading now? Show everyone.
0.
69.
Zero.
Show everyone.
0.1.
Yeah.
0.1. 0.
Okay, does everyone see what I've just done? Okay. The camera straight.
Cameraman, focus.
Okay, we've learned a lot just from that experiment. We've learned how to use a multimeter, Brian. How to hook up a multimeter. How to set the multimeter right. But when we had an open circuit, we had
12 volts.
12 volts. When we had a closed circuit, we had
0 volt.
0 volts. Okay? Does that help?
Yes.
Okay. So,
Break.
right, not yet. So, can you see what's happening here? Closed circuit,
0 volt.
open circuit.
5 volt.
Why is that? Okay. When we've got 5 volts going, here, okay, and we're measuring from there to ground, we're actually measuring along the resistor back to the power source, okay? We're reading that because there's not a complete circuit, okay? We're reading 5 volts. But we're on the ground side of the resistor, aren't we? So when we close the circuit, we take the voltage drop. That 5 volts is dropped down to 0 because now we've got a closed circuit because there's a path to ground. And that circuit now becomes 0. If we're going to read this side of the resistance, what are we going to see?
5 volt.
5 volts, regardless of whether it's open or closed. Okay?
Yeah.
Do we understand?
Yes.
You listening, Abby?
Let's go.
Okay. So, closed circuit, 5 volts.
Closed circuit 0 volt.
Okay, I'm going to ask you this question. If I've got a voltage sensor circuit here,
Yes.
why isn't my resistance going to ground through there? Why?
So there's a relay.
No?
Because there's a switch there to ground.
Yes, but say for example that switch is open like that, why isn't the voltage going back to ground through there?
Going to the switch close.
There's a diode.
No?
Going to the
Resistance.
No? Alright, maybe I should ask this question.
Some distance. Yeah.
Okay,
Change the R.
alright. How come if I go, I put my volt, can I have it?
switch box.
Yes, sir.
Which one? Come here. Come over here.
Go, go.
Alright.
मेरा दिखाया था ये और तो डिजाइन
If I go here, this is my window switch, and I go to here, how come I'm not making this switch work now, or this motor work, because I bypassed the switch? What's my voltage?
1.96
Why is it not going through this meter and grounding out? Anyone know? Valid point.
open circuit
So I can't understand what you're trying to say.
Because you have a big resistance on the multimeter.
What'd you say?
You have a big resistance in your multimeter. That's why it's
Yes.
low.
Exactly, because it's got a high impedance.
What?
A high impedance, meaning there's a high. Yes.
But if you want to make it happen, just put a wire.
Yes, that's correct. I'll short circuit it. But look, I'm trying to get across that there's not enough capability of current to flow through this meter, nor is there on that sensor there. This is like a voltmeter, okay? And it will read 0 volts or it will read 5 volts, and that communicates to the computer, so the computer will use that to activate whatever it's meant to do, whether it be a motor for a window winder or whatever it is. It will then activate through that input, okay? Am I making myself clear or am I confusing you?
It's a bit confusing.
All right.
It's all clear, sir.
Some people are clear, some aren't.
It's not very clear.
I think
Okay.
you need a break.
You'll get a break in a minute. I'm trying to help you understand how a circuit works, okay? And how to look, Brian, you looking? How to read a wiring diagram also. And if you look at a wiring diagram and you see an earth there, you'd almost think that that would be what is a completed circuit, of course, but it's not enough to draw that down to 0. In other words, there's nothing between here and there. When that gets turned on, that switch gets turned on, it gets brought down to 0 volts, okay? It gets down to 0 volts because there's no resistance. It's just straight into a ground, okay? But when this circuit here gets completed, it's got a huge resistance, so it doesn't bring that circuit down to 0. Does that make sense?
Yeah.
Does it make sense? No?
Yes.
This multimeter also completes the circuit, but it's such a high impedance circuit that it doesn't bring it down to zero. It just reads the voltage. Does that make sense?
Yes.
Someone asked me, how do you know what voltmeter to buy or multimeter to buy? It has to have a high impedance of about 10,000 impedance or thereabouts to be a good one, okay? And that could be the difference between a good one and not such a good one, okay? It has to protect the circuit it's testing. If it can test it, it's got to be a high resistance, okay, so that it doesn't bring down the voltage to zero. It just reads the voltage.
तो दुई तीन वोल्ट के चाहिए कि हमें समझ में
Yes.
What does impedance mean?
High resistance, I guess. I'm not sure. I just know the word. It means it doesn't. I know what it means. It doesn't draw hardly any current at all. There's very little. There has to be some current flow, but such a minute amount of current flow, okay, that it doesn't really draw the circuit down. I could leave my voltmeter on this battery all night, and you'd hardly notice any drop in the voltage because it doesn't drain the battery because it's such a low drain on the battery. Does that make sense?
Yes, sir.
All right. I hope I haven't lost anyone. Sometimes I understand something and I think that I'm communicating something and then I find out I'm not. So it's important I know that I've got across to you what I need to get across. So please let me know if you're not sure of what I'm trying to say. Okay? You know, Brian?
Yes.
Okay? All right, hopefully. All right, who said they wanted a break?
Brian.
All right, turn that off, please.